So what forthcoming trends do you see in the field and the future challenges that are facing computer architects?
So I think the single biggest challenge facing architects, which should be keeping the entire semiconductor industry up all night, is essentially the inevitable end of Moore's Law. So Moore's Law says that every 18 to 24 months, the number of transistors per die will double. And for a long time, the entire field has basically ridden this technology scaling. Yes, architects make tremendous contributions in terms of microarchitecture, in terms of the instruction set design, in terms of how to expose this to software. But a lot of the benefit really comes from the fact that in 2 years, I can put more transistors on a die. Those transistors get faster, and to first order, the power density doesn't get too much worse. So I can get, and the cost stays about the same too. But within the next decade, I think it's becoming increasingly clear that that technology scaling will either stop or slow tremendously. And it just has to do with physics. We're getting now to the point where we measure transistors in 100 atoms. And we're just going to run out of space. And they're not going to look like transistors. They're going to look like quantum devices. So on one hand, this is a very scary situation because now we have this kind of impending end of this technology scaling. But on the other hand, it's a tremendous time to be a computer architect because I imagine in the future, architects are really going to be the only game in town. You're going to have a potpourri of different technologies. You're going to have maybe molecular computing, different type of semiconductors, maybe a little quantum computing in terms of high performance computing. You have this potpourri of different types of technologies. But I don't see anything coming in and replacing silicon CMOS. And it's kind of analogous to how right now if I want to build a new building, I am sure I could go to material scientists and they could talk to me about exotic polymers that have so many benefits compared to steel and concrete. Yet what do I use to build a building? Steel and concrete. Because that's what the infrastructure is developed, that's what everybody knows how to use, and that's the kind of the best materials broadly. I think it'll be the same thing. So silicon CMOS technology will be the standard. There might be some potpourris of different technologies. And so what will really differentiate one system from another system is not the technology, but what you do with it. And who decides what we do with the technology? Architects. Architects are the ones that differentiate one chip from another chip in a given technology node. So architects will become the only game in town. And architects will have a much bigger role in terms of designing future chips. I can almost see a resurgence in terms of chip design startups and basically an emphasis on new types of chips that basically exploit whether it be applications in specific ways, classes of applications, new types of accelerators. So I think that makes it a particularly exciting time to study the field of computer architecture specifically and more broadly computer engineering.
Professor Christopher Batten from Cornell University. Chris, thanks for joining us.
It was a pleasure. Thank you for having me.